Okay, this is the video for Geometry Honors for Thursday, April 30th. Okay, so here we go. The aim today is circle vocabulary, and there's a lot of it. So, first of all, a circle is a set of points in a plane that are equidistant from a fixed point, which is the center. Okay, everyone should have printed out this sheet already so that you could fill this out as we're going along. A circle is usually named after a center. We usually use the letter O to represent the circle center, but it doesn't have to be an O, okay? But it's named by the center. Segment OB starts at the center and ends at a point on the circle. OB is called a radius. And that you already know anyway, okay? Segment AB starts at a point on the circle and ends at another point on the circle, and it passes through the center. AB is called a diameter. And segment DE starts at a point on the circle and ends at another point on the circle. DE is called a chord. First page done already. That was fast. I'm doing a lot of pages with you. Okay. CF is the whole line or line segment that contains a chord and intersects the circle twice. So CF is called a secant. A secant hits the circle 2 times, and that's not to be confused with a tangent, which intersects the circle at exactly 1 point. So GI is a line or line segment that intersects a circle at exactly 1 point. It doesn't enter the circle. Okay, so far so good. We're already on number 7. Now, is triangle AOB isosceles? Explain. Well, all radii of the same circle are congruent, right? These would have to be congruent. So yes, because OA and OB are both radii and all radii of the same circle are congruent. So triangle AOB has 2 congruent sides, making it isosceles. So triangle AOB is isosceles because it has 2 congruent sides. Okay, so far so good. Find the length of BC. Okay, well, because all radii of the same circle are congruent, if that's 10, then that's 10, making the whole segment 20. The hypotenuse is 20, and we're trying to find this. So how do you find the missing side of a right triangle? You use the Pythagorean theorem. X squared plus 12 squared is equal to 20 squared. So x squared plus 144 is equal to 400. Subtract 144 from both sides, x squared is equal to 256. Take the square root of both sides, x is equal to 16. So BC is equal to 16. Page 2 done already. How fast are we going? So fast, okay? But there are some more pages to go. And again, you can pause the video at any time. Don't forget that. Okay, we're going to be making a lot of diagrams here. Questions are harder when they don't give you a diagram. But if you know how to use the vocabulary, it certainly helps. Circle O with radius OM and diameter NM. Circle O with radius OM and diameter NM. OM and NM. So that's what satisfies both, right? So that's number 9. Number 10, circle O with the radius OA and chord AD. That's the radius, that's a chord. Easy peasy. Okay. Shall we? We shall. Number 11. Circle M with diameters AB and CD. Circle M. So this time, my circle is called M. AB and CD. That's all it is. Circle W with chords GH and XY. GH, XY. Those are what chords are. Line segments whose both endpoints are on the circle. Circle O with chords AEB and CED. That means they're intersecting each other. A, watch this. AEB and CED. Circle K with tangent AB. Circle O with external point P and tangents AP and BP. AP and BP. Later on, you're going to learn that if two tangents are drawn to a circle from the same point, they must be congruent. But you didn't learn that yet. Circle O with external point P and secants AP and BP. Circle O, external point P. Okay. AP and BP. Those are secants because they each hit the circle 2 times. 17. Circle O with external point P, tangent AP, and secant BP. Circle W with diameter AB and secant bx. Secant sitting it twice. 1, 2. Okay, that was really good. Looks pretty neat too. Those are some circles. Good job, Mr. Edelman. Okay, next up. Wow, it's been much faster than I thought it would. Maybe I'll get a little more done with you. A little more we do, a little less you have to do. Very important. A central angle of a circle is an angle whose vertex is at the center of the circle. A central angle of a circle is an angle whose vertex is at the center of the circle. So here's the center of the circle. So let's say this was 85 degrees. Well, that would also be 85 degrees then, as you'll find out in a minute. But that angle there, that's the central angle. Angle whose vertex is at the center. The measure of an arc is equal to the measure of the central angle that intercepts that arc. So let's say you have this, and we're trying to find out what x is. And they told us that this was 250 degrees this side, this part here, this major arc, the bigger one. Well, then this arc here would be 360 minus 250, which is equal to 110. So this here would have to be 110 degrees. And then the central angle is the same as the arc. So if the question is, what is x? Then the answer is x is equal to 110 degrees because it is the same measure as the arc. A blank arc measures less than 180 degrees. A minor arc measures less than 180 degrees. And a blank arc measures more than 180 degrees. We usually name them with 3 letters. That would be a major arc. But I didn't draw my diagram here, so hold on. 2 more diagrams. So if this was B, and this was A, and this was C, so AC would be a minor arc. But over here, A, B, C, arc ABC would be a major arc. So here AC, if I do a little shading, talking about that. And here we'd be talking about that whole part. Okay. Wow, 14 minutes in, we did 4 pages, right? How many pages? 1, 2, 3, 4. Way to go. Okay, so what do we have left? We have 2 pages left, but they're quick answers. However, I am going to do this one with you, 23, and you're going to be left to do 24, 25, and 26 for homework. So, here we go. Trying to get the whole thing in there. I think I got it. Okay, angle AOC is 25 degrees. Well, we also know that linear pairs are supplementary. So 180 minus 25 is 155 degrees. And we also know that vertical angles are congruent. If that's 25, that's 25. If that's 155, that's 155. And then you just learned a minute ago that when you have central angles, angles whose vertex are at the center, then the measure of the arc is equal to the measure of the central angle. So therefore, this is also 155 degrees, 25 degrees, 155 degrees, and 25 degrees. Okay? So you have to start filling everything in. Angle COB is 155 degrees. BOD is 25 degrees. DOA is 155 degrees. Arc AC is 25 degrees. Arc BC is 155 degrees. Arc BD is 25 degrees. Arc AB, add them up, for the whole arc AB, it's 180, but we also know it's a diameter, and a diameter splits a circle into two halves, each of them being 180 degrees. Arc ACD here is 180 plus the 25 is 205 degrees. And arc CBA is everything except this 25. 360 minus 25 is 335 degrees. Okay, so basically, all you have left is 24, 25, and 26. Okay? Don't forget in 24, it says POR is congruent to QOS. So when you find out how much is left out of 360, all of these have to add up to 360. Let me help you a little bit. Angle POQ is 100. And angle ROS is 40. This plus this plus this plus this have to add up to 360, but these two must be the same. I'm not giving you more than that, okay? You can call them both X and add them up to 360. And then for the other ones, they give you information. Just make sure you put it in and use it. Angle AOC is 2X. Angle COB is X plus 90. And angle AOD is 3X plus 20. And it tells you angle AOC and angle COB are supplementary. AOC and COB are supplementary, which means that these are going to have to add up to 180. You'll figure out what X is, you'll plug it in, and then all of them have to add up to 360. And the rest are definitions, which you should be able to do. Your homework is to complete the rest of the sheet. So I did 23, you have to do 24 through 28. 24 through 28. Hope all is well. Have a good day. 24 through 28 due tonight. Bye.